Hi everyone, in this video I'm going to show you how to convert hexadecimal or octals to binary and convert them back to hex and octal. So before we start that, we have to learn something about hexadecimals and octal. We're going to start with octal numbers. So as we know, octal numbers are base 8. And base 8 means 2 to the power of 3. Sorry. And so that means when we say base 8, it means each digit of octal can get a value between 0 to 7. For example, one of the octal numbers that we can come up with is 257. And this is octal number. So we don't read it at 257, we read it 257, base 8. So since each one of these digits can get a value between 0 to 7, and this base 8 is 2 to the power of 3, that means for each digit of octal, we can have 3 places in order to convert that to the binary. So let's do that for this number. So we will put 1, 2, 3, 7 places for number 7, which is base 8, and then 1, 2, 3, another 7 place for 5, which is base 8, and then 1, 2, 3, another place for number 2, which is base 8. So what we do is that we convert each one of these number, which is 7, 5, and 2, into their binary numbers. And then when we put all of these together, we will get the octal number. So if we want to convert 7 to binary numbers, first let's put the values for each one of these. I'm going to change my color to this color, and then this is going to be 2 to the power of 0, this is 2 to the power of 1, this is 2 to the power of 2. So this is for number 7. Again, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, again 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So I'm going to change my color again to somewhere in blue, and then here I'm going to put 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4. So this is 1, 2, 4, 1, 2, 4. So what we do is we add these numbers and figure out how many numbers do we have to put 1 for to get the number on the top. So in order to get 7, I have to add 4 plus 2 plus 1. That will give me a 7. 4 plus 2 is 6 plus 1 is 7. Then for 5, I can add 1 here, and I can't add 2 because it will become 6, so I will put 0, and then I have to add another 1, that will give me a 1. That will give me a 5. For number 2, I have to add 0 here, 1, and another 0 here. So that will give me this number. So 257 base 8 is equal to 1, 0, 1, 0, 1, 1, 1, 1. This number is the number in binary equal to 257 in octal. In order to turn it back to decimal, you can just go from here to here, 2 to the power of 0, power of 1, power of 2, power of 3, 4, 5, 6, 7, and convert that to decimal. So you can easily, whenever you convert any number like octal, hexadecimal to binary, you can easily change it to decimal, or you can change it to hexadecimal, and I will show you how to do that later. But for now, know that when you have an octal number, you have your base 8, you have 2 to the power of 3. That means for each digit of octal, you can put 3 places, and you can find each digit individually and get the number in binary. So this is our octal. I'm going to open another page, and now we're going to learn how to do, I'm going to change my color back to white. So now we're going to learn about how to change hexadecimal to binary. In order to do that, we need to know that hexadecimal is 16, is base 16, and 16 is equal to 2 to the power of 4. So that means for each digit we have 4 places. So if I have a hexadecimal number here like A5F, and I want to convert this to binary number, let me just put the equal of each of those letters here. So 10 is A, 11 is B, 12 is C, 13 is E, it is D, and 14 is E, 15 is F. So now I want to convert this to a binary number, a base 2. This is base 16. I want to find it in binary number. So I'm gonna put, as we know, 4 places for each of the digits that we have there. So this is for F. This is for five, and this is for A. Okay, now let's start with F. First, let's put these values down here. So I'm going to use this color. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. The same thing for all of them. 0, 2 to the power of 1, 2 to the power of 2, and we forgot to put another one, 2 to the power of 3. And I'm going to change my color to a blue one. And this means this is 1, this is 2, 4, and 8. 1, 2, 4, 8. 1, 2, 4, and 8. Okay, now we have to add these numbers together until we get F. So I can add an 8 to it, and then 8 plus 4, it will give me 12. So I can add 1 here, and then plus 2, it will give me 14, and I can add another 1 to it, and it will give me 15, which is 15 is equal to F, so that means I got that number right. And then after that, I'm going for number 5, so I can't put 8 in it, so I have to put 0. I can put 4, I cannot put 2, I can't put 1. So that is the number for 5, and then A, which is equal to 10, I can put a 1 here, I cannot add a 4 to it, and I can put another 1 here, and I cannot add 1 to it. So this is my final number in hexadecimal. So this number in binary. So this number is 1010 0101 1111. So this is my number in binary for A5F. Again, in order to change it to decimal, you can just do 2 to the power of 0, 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you can convert it to decimal. This is as easy as it gets. And then, so right now, we learned how to convert hexadecimal to binary and octal to binary. Now, what if I want to convert a hexadecimal to, let me first open a new page. Okay, so now I have a number. For example, let's choose a small number because it won't take a long time. I'm gonna put A was 10, and then B 11, C 12, B, C, D 13, E 14, and then F, which is 15. Okay, so I have a hexadecimal number here and I want to change it to decimal. My hexadecimal number is E9. This is base 16 hexadecimal number, and I want to convert this to a decimal number. So the way to do it, well, there are a couple of ways to do it. You can either divide this by 10, as we see in the other video, or the easiest way to do that I'm going to do here is to convert this to binary and then convert your binary number to your decimal number. So in order to convert this to binary, I know that 16 is equal to 2 to the power of 4. So that means I have 4 places for each of the digits. So I have 1, 2, 3, 4, and then 1, 2, 3, 4. So this is for number 9, and this is for my E. I'm just gonna write the numbers here. So this is 1, 2, 4, 8, and this is 1, 2, 4, 8. So here I want to get a 9. I can put a 1 here, now I have 8. I have to put 0 for these ones, and I can put a 1 here, now I will get 9. So for E, E is number 14. So I can put a 1 here, now I have 8. I can put a 1 here, now I have 12. I can put a 1 here, now I have 14, so I will put a 0 here. So this is the number in binary. The number in binary is 11101001. This is the binary number of E9 in 16. Now I want to convert this number, which is E9, to decimal. So what I do is I will consider all of them as a one number. And instead of dividing them 4 by 4, I will consider all of them as one number, and I will start putting places to add them together. So that means I have 8 places here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And then this one, let me change the color to yellow. So now this one is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. That means this is 1. Let me change the color. So that means this is 1, this is 2, this is 4, this is 8, 16, 32, 64, I'm not mistaken, this one have to be 128. Okay, so now I have to add, I have to see which ones are 1. So that means I have a 1 here, I have a 1 here, 1 here, 1 here, and then this is 0, so we don't have this, and this, there is a 1 here. Oh, wait a second. 1, 2, 3, 4, 5, 6, 7, 8. We made a mistake here. So this is 1, 2, 3. We don't have this number. And then we have a 1 here. We don't have this. We don't have this. We have a 1 here. So that means I have to add 128 plus 64 plus 32 plus 8 plus 1. Okay, now let's get our calculator. So now I will add 128 plus 64 plus 32 plus 8 plus 1. This will give me 233, and 233 is base 10 of E9. So that means E9 is equal to 233. This is how you convert it, and let's do another one for octal as well and see how does it work with octal. Okay, for the octal number, I'm going to use 771. This is in octal, and I want to convert this in decimal. Okay, so 71 in octal, as we said, 8 is equal to 2 to the power of 3, so that means we have 3 places for each one of these digits. So for 71 we have 1, 2, 3, this is 1, and then 1, 2, 3, this is 7, which is base 8. Okay, so this is, let's just put the numbers 1, going to change the color again, use green probably, and then here I will put 1, this is the place of 1, this is 2, this is 4, and then 1, 2, 4. Okay, in order to get 1, I have to put 1 here and the rest of them should be 0. In order to get 7, I have 1 here, so now 4, 6, and then 7. So this number 71 base 8 is equal to 111001. This is base 2, so our binary number is going to be this one. Now, if I want to convert this into decimal number, I can easily put the 1, 2, 3, 4, 5, 6. So I have 6 places. 1, 2, 3, 4, 5, 6. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and 2 to the power of 5. So that means the value of this number is, oops, sorry, this one was 2 to the power of 5. So that means this is 1, this is 2, this is 4, this one is 8, this one is 16, and this one is 32. Now I have 1 here, 1 here, 1 here. I have 0, so this will cancel out, this will cancel. This one is 1. So that means I have to add 32 plus 16 plus 8 plus 1 to get 71. Okay, so I add 32 plus 16 plus 8 plus 1, and this will give me 57. 57 base 10, so this is equal to 57. Okay, so this is how you do it. This is how you convert octal to decimal. There are so many other ways to do it, but the easiest way is to convert your number into binary and then convert your binary number to decimal number. Now let's just check it and make sure that this is actually working, that 57 in decimal is actually equal to 71 in octal. So I'm going to open another page, a new page, and remember 71 and 57. Let me write it down before I forget. So I have 71 octal, 57 decimal. In order to check it, let's check it from the division system that we have. This is not good. I'm going to change it to blue color. Okay, I have number 71 here, and then I have number 10 here, and remainder comes here. So if I divide 71 by 10, it will give me, let me change the color. Actually, sorry, we wanted to go from 57 to 57, which is base 10, to base 8. So we're supposed to make it in a different way. That means I'm just gonna erase these two. Okay. So now I have number 57 here, and we want to get what is it in base 8. So that means from 57 we have to get 71, and that means the way that we calculated it would be right. So first I'm gonna divide 57, sorry, I'm gonna divide 57 divided by 8 is equal to 7.2125. 7 will come here, 0.125 will come here, and 0.125 multiplied by 8 will give me 1. This is my reminder. And then again I have to divide 7 divided by 8. It will give me, here is 0 and here is 0.875. That means 0.875 multiplied by 8 will give me 7. And then we read it from the bottom up. That means we will get, let me change the color to something like that, and that means it will give me 71 and this 71 is equal to this 71, that means the procedure, that means the way that we did it, converted to binary and then converted to the other number, works. Because we prove that 71 is equal to 71 after using 57. I hope you enjoyed this video and learn how to convert from different number systems to another one. You can use this to change hexadecimal number to binary, and then hexadecimal number to decimals, octals to hexadecimals. You can change any binary, any number systems to any other number systems. And the easiest way to do that is to use binary. But you can mix and match different type of procedures that we use in these 3 videos of number systems, and you can get any numbers that you want. Thank you very much for watching, and see you in next video. Bye.